published on the Harvard Dataverse, and anyone can download it. We have very detailed metadata, and there's probably not time. I'd like to have shown you the metadata, but it's well worth taking a look at the metadata, because that's an important development in this in this next phase of the work. And the production of the metadata is an output of the model. So as soon as we run a model, the metadata are generated, and the results are sort of presented alongside that. And that's an important thing that shows how accurate we feel the data are, what the sources of all the data are, various metrics on how up to date they are and stuff like that. So that's an important upgrade, and it's a collaboration between FAO, the University Libre de Bruxelles, which is where Marius is from, Ergo, which is where my colleague Willie Wint is from. Hilary has been involved at various stages, particularly while I was there for the a few years ago, and we kept this sort of show running from there. And the University of Oxford has provided a lot of input data. And those are the objectives: to collate, harmonize, and disseminate global subnational livestock data, to predict the livestock numbers in areas with missing data, and to spatially disaggregate estimates within large population units. So for districts or provinces, we can break that down into where we think, based on the models, that the densities are likely to be highest or lowest. The evolution of the gridded livestock of the world, we started off in 2007, and we had Willie Wint really did all the modeling work for that, and that's when we published this book after a number of years of collecting data and modeling separately for each region. That's where it started. Marius then became involved, and he's an extremely clever programmer, and he made the whole process much more efficient and robust and readily replicated. So from it being a sort of ad hoc job of covering the whole world piece by piece, we then automated the whole procedure in GLW2, and now in GLW3 it's really a much slicker operation, and the whole modeling. And I think now it's fair to say that the modeling we've gone about as far as we can with, and the limiting factor now are just the quality and the detail of the input data. So we can very quickly update models as and when we get better data on subnational distributions, and getting better data for some areas will improve the quality of the predictions in other areas. So it's now a matter of focusing on the data quality and moving it to the next stages. And I think the very next stage is estimating, moving from livestock numbers to livestock production amount. Okay, it's got lots of applications. We have this on the left. We have these sort of 4 areas that we use as a framework for sustainability: food and nutrition security, livelihoods and economic growth, animal health and animal welfare, and human health as it relates to that, and climate and natural resource uses. This is a framework that we're using, and I'll talk about this in one of the groups tomorrow as well. And there are applications that have been found in all of these different areas of using the data. So they're widely used, and there's a lot more that can be done with it. So encouraging people to do as much as possible with it. This is the process of producing the data, and I don't really have time to go into this in detail, but we start with the reported statistics, and then there's the process of georegistering all of those statistics, and then that comes up with observed livestock densities, and then we have a bunch of predictor variables and a bunch of models, and we come up then with the statistical models of the predicted livestock densities. And then the input data come from many different years, of course. So what we do then is tie that to some FAOStat statistics for a standard year, so that we have a standard base year for each of the maps. And 2010 is where our data currently that's the median value of the data, that the observed data. So that's what we standardize it to, is 2010. So then we come up with our predicted densities, and then we could generate the metadata, and it's now published on the Harvard Dataverse. We use that. That's a nice system for publishing data sets, and it's fully open access. These are the different maps that we have, the eight different species that we have, and these, so we have these distribution maps for each of those 8 species, different scales. Obviously, they have different sort of sensible densities, so we have to use different scales. And these are all downloaded as GeoTIFF files. They're very simple nowadays. You don't have to produce complicated ArcInfo coverages. It's much more straightforward to make them easily accessible. And of course, they can be visualized by people just as graphics like this, or then they can be imported straight into GIS systems. So it's all very nice nowadays. We have 2 different types of model. So we have the decimetric, which is the modeled version, and that's where we've spatially disaggregated the data to this 10 kilometer spatial resolution. But we also produce a simple version of area-weighted densities. And that's largely for people who want to use the stuff in models and who would want to avoid circularity with the predictor variables that we use to do the modeling. So that's those are the 2 products that we basically produce. Yeah, that's essentially the observed data presented in a GIS format on the area-weighted stuff. It's important to these livestock distribution maps are of limited value in their own right, because the livestock need to be taken in context, of course. So the diversity of livestock systems is super important to bear in mind when doing analyses with these. And this slide just here gives an idea of the diversity of livestock systems. And obviously in the different systems, livestock have different roles, face different constraints, and so on. So we need to use this stratification when analyzing the stuff. And we're producing maps as well on livestock systems, and those go hand in hand with the livestock distribution maps. So the GLW3 was recently published. We had a paper in Nature Scientific Data recently, which just describes and explains the data set. That provides links to this new FAO website, which we've constructed, and the data can all be downloaded from here, or you can go straight to the Dataverse for the data. This website that we have now has 3. You can't actually read them because it's a bit blurred, but we have these 3 tabs along the top there. The first one is the global distributions. The second tab is the livestock systems. The third tab there is links to a set of resources, to all the publications and so on that have been generated as input to this and also from it. And the next tab that comes along when we get round to it will be about livestock production amount. And that's where we're making some significant progress at the moment in transforming these densities into livestock production models for the major commodities, for meat, milk and eggs. I think that's it. Thank you.
Great.
Thanks, Tim. Any questions for Tim? Andrew?
Is there any ability to go? Do you have any ability to go in and do some post-validation of that? Just, I don't know, sometimes the national data sets, even subnational distributions are pretty wonky.
Yeah, no, that's a question that's often asked, and the answer is not really systematically, but it would be nice. I think we don't have resources to go and ground truth it properly, but what we do, and we have represented in the metadata, we have some detailed statistics on the internal validity of the models. So and we know for different areas how good the quality of the models are, but the actual validation on the ground is not something we've done. We've done a bit of work by degrading the input data sets when we have multiple levels. So sometimes we can put in province level data, for example, for a country, and then we compare the disaggregated results against district level data. So that's one of the things that we've done, and we've used that to determine which models to use, and so that's been part of the process of developing the current statistical system, but we haven't done any actual ground truthing.
Good. Any other questions? Or? They're looking for their coffee, I think. Okay, great. Thanks a lot, Tim.
Thanks.
Another round of applause for Tim.